Hi, everybody. Is this good? Okay. So, Craig Danton, I'm the VP of Product at Enigma. And thank you, AWS, for having us here. I'm super excited to be at the conference. So today, I wanted to give you a brief overview. You're probably not familiar with Enigma. You probably may have, if you've heard of us, you've probably heard of our public data work. You can go to enigma.com and check that out. I wanted to give you a little bit of an understanding of some of the enterprise work that we're doing. I'll walk you through some of the data science problems that we have, how AWS is helping that, and some specific use cases for how that's applied to financial services. So if you think for a second about the decisions that businesses make 100, 1,000, maybe even tens of thousands of times a week, as opposed to just those one-time insights, that's what Enigma is focused on. We focus on how you inject data to the point of decision, whether that's a computer or a person, and how you just make it a little bit smarter. When you look at companies much like Amazon, Facebook, Google, a lot of what set them apart is actually they've moved away from this just one-time insight. Okay, let's take a bunch of data from our data stores, crunch it in Spark, find a one-time insight, find that needle in a haystack, and present it to a board, to their exec team, and then make a decision. No, they're driving their products, they're driving their everyday decisions with data. That's easier said than done. So Enigma is actually focused on three ways that we can help companies do that. And we work mostly with Fortune 500 companies, so large companies that have been around for a long time, different problems to some of the new scaling startups. So the first one is incomplete information. So when we actually go to our customers, when we do see them using data to make decisions, it's generally the data that they happen to have at hand, not the data that they should be using, not the data that's actually trapped within the silos of their entire organization, and actually certainly not the data that's outside of their own four walls. And that's where Enigma got its start. We started as a public data company, trying to acquire a whole bunch of public data sets from governments around the world, things like shipping information. So what's being shipped in and out of this country every day, down to the Justin Bieber t-shirts or the merchandise coming from China, to political filings, to SEC data, you name it. That's what we got started with. And we actually had to cleanse that, link it together, and apply it to enterprise workflows. So this is one of the first value propositions we have to our customers, is bringing that data to bear on their decision-making workflows. Second, legacy systems. We are at an AWS conference, so this is a pretty close to home thing. It's that most of these systems have been around way longer than before anyone was talking about big data. When you start moving away from what we call clicks data, but data really generated in the IP protocol of the internet, and you don't have things like cookies, IP addresses, and standardized login information, you start entering this murky world. And that's really where Enigma's thrived for a really long time. So not only are you trying to take these systems that were never designed to talk to each other, but you're trying to do that in a routinized way. You don't want to just build off one-off technology, having to build an entire workflow, change somebody's decision-making patterns, and then having to do it again and again and again, deploying more and more. So the way we take that approach is actually really modular steps, capabilities that we can apply to many different problems. And lastly, the problem of disconnected data sets. So as I was saying, when you move from this IP-driven data, this kind of clicks-driven data, to what we call real-world data. So we're now dealing with companies, people, places. Those are not defined objects, right? As we know, we've changed our names over time. Companies have complicated ontologies or complicated entity structures. Like, you could imagine JP Morgan having thousands of different entities that they have. So how do we begin to link this data together and get a consolidated view? Because that's what we need to do if we're going to apply this third-party data, external data, or even data within the silos to a given problem. So this is the third problem we're going to talk about. And that's really what I want to focus on today, is how do you link together data sets in a scalable way and bring that to bear to create ROI. So I'm going to start with a use case in the insurance space. Now, the major problem here is when you start looking at small and medium-sized businesses. So actually, take a look around and you can see various restaurants and things like that. Look around this organization or around this building, you're going to see bars, restaurants, small delis. Those are incredibly risky businesses and actually make up the large percentage of the economy, as you can imagine. Underwriting those is incredibly difficult. They don't actually appear in things like LexisNexis, Dun & Bradstreet, traditional sources of data. So how are you meant to get an understanding of their risk? And I like this use case because really it's an illustration of how Wild West public data is and what you need to be able to do in order to create value here. So I chose a business here called Walk and Roll. Now, if you flew into this conference through JFK, this is actually a restaurant kind of in this same setting that actually applied for insurance through one of our systems very recently. So let me walk you through what I mean by linking and some of the challenges of how you can bring this data to bear. So first, we cast a super wide net, right? So we're looking up Walk and Roll, and I apologize for any of you who can't read the font, but we're essentially casting a super wide net across all the entity information that we have. Some of it seems kind of rock and roll. Okay, that's somewhat sounding the same. We've got places, we've got the zip code, so maybe we can use a location search, but we cast that wide net. We choose two entities that seem similar. Now, this is pretty fuzzy, right? It's not an exact name match, but it happens to be a zip code and name match, so we're good. Let's take that for now. We link those things together and we begin to augment. So I mentioned that we have many different data sets. Let's take corporate registrations, for instance. So this is where we can get owner information and owner management, registered agent information, things like that. So, okay, we're getting a bit of a profile for what this business might be about. Okay, now we got the restaurant, the famous New York City restaurant inspection data. You'll see the A, B, Cs all around New York. So we've actually got a history of that data. That's a good sign. That means the business has been around for a couple of years. They've got 2 inspections at least. I'm not sure the order, but hopefully it went from B to A and not vice versa. And then we go to related information. We see that the actual, look at the many different representations of the same company here, and they actually have H-1B visa applications. That's tremendously expensive to do, right? You're applying through lawyers to have people come to the States and work. That says a lot about the business we're talking about. They're investing, they're hiring people, they have many different assets. Okay, that's also a good sign. Now we look at the owner. It turns out they're actually linked to another enterprise that is using to own a large private residence, it looks like, on 61 Christie Street. Okay, I'll pause there. I think you guys get the point. We're looking at many different data sets and how they can be linked. So we've now got a picture of this. I mean, I think it's pretty clear that Walk and Roll is a legitimate business. They seem to have a track record of at least being inspected. Who knows in which direction it's going. But in other words, we've managed to actually build a profile of this business that had almost no footprint in traditional sources of data. So this has been one of our major use cases as we've grown as a company. Let's put aside the actual data here and start thinking about, this was really easy to do for a human, right? If we had Google search, if you had Google Maps, you could probably do this. It might take you, I mean, depending, if you had Enigma, you could go online and do this. But how do we do this for tens of millions of entities around the world, right? That's not easy. It's a lot of fuzzy matching. It's a lot of entity linkage. And that's really what I wanted to talk about today in regards to our technology stack. So Enigma uses Spark and EMR in our entity linking stack, and I just want to walk you through some of the problems that we go through at each stage and how AWS has really helped us do this. So first of all, ingestion. I mentioned that we have hundreds of data feeds coming from governments. Some of that data is coming in at a quarterly basis. Some of it is coming in many, many times a day from the SEC. So we've got a real scalable variable ingestion system where things fail for all types of reasons. We've built infrastructure to get visibility into that, and AWS has really helped us be able to scale up and scale down the amount of ingestion resources that we need dynamically. And now we've helped companies do the same thing to actually help for their third-party data when they're actually buying data from externally. Now we take that data and we store it in a storage format, right? We store it in S3 in Parquet. And we actually do very little transformation on our data. That's kind of a core tenet of who we are as Enigma. We bring in data pretty true to source. And that's mainly because we actually believe if you're going to do transformation, if you're going to do cleansing, you should do it with the application in mind. And because we're actually solving a variety of problems, we don't want to do that necessarily and introduce bias before we know the problem we're going to solve. So we store it relatively raw in S3 formats. And now this is kind of where it gets a little bit more interesting. So I've been talking a lot about entity structures. I even accidentally said the word ontology. And that's because that's exactly what we do. For those of you not familiar with the concept of an ontology, it's really just a model of the world, right? So companies might have these 50 attributes: names, address, owners, CEOs. Companies might have these, and locations have these, and we can model many different things, products, you name it. So once you actually have this entity structure, this model for the world that you think is going to be helpful to you, you load in your data set and you map those things together. And we have a series of tools to help us do that. Now we have a model. With which to work. So based on that, we can actually do our cleansing. So if you tell us that something's a name, or we classify something as a name automatically, we can send that to a cleansing process that will actually handle people's names or companies' names accordingly. If you send us an address, then we can make sure that we send it to our geocoding service, and we have that cleansed, normalized, and we have a lat long appended to it. That makes it way easier to do kind of location-based matching. So all of this, now we're kind of taking all these records from these public data sets and we're loading them up, but really they're still individual. They're not connected to each other. You've got an SEC filing over here, you've got a shipment over here, you have some Chinese data over here. It's not connected. How do we connect it together? This is really what we invest a large portion of our engineering efforts in, which is entity resolution. So for those of you familiar with this process, really all you have to do, you're taking hundreds of millions of records on either side, and you're almost comparing each one individually, right? You're doing a pairwise comparison saying, are these records linked? And then you're kind of putting a score next to that. Now there's many ways you can optimize it to reduce the amount of comparisons that you have to do, and that's really the algorithms you have to run. Others would be here to the end of the time just doing one analysis. But really, regardless of how much you optimize it, it's still a computationally intense process. We're talking about exponentially complexity there. So this is where the spot instances actually for EMR and that Amazon offers has been fantastically helpful for us. If we actually had to maintain an infrastructure required to do entity resolution months on end, or reserve instances or anything like that, it would be costing us tens of thousands of dollars more a year to do this, and we'd actually be limiting ourselves in terms of the number of models that we actually can build and the number of different data sets we can bring in. So we actually spin up large clusters for a matter of hours. We run our entity resolution processes, we link all that data together, and then we begin to collapse it down into a standardized entity list. Now we have our entities resolved, we can actually apply it to all different types of workflows. And that's really the bread and butter of what Enigma does in order to be able to link together public and private data sets to find value. I mentioned that I'd talk about some of the applications. We talked about insurance earlier, but I really want to highlight some work that we're doing in financial compliance. So, as some of you might be familiar with, I'm not sure where the audience is from, but we've got a huge amount of regulation going on in this country, specifically in regards to money laundering, know your customer, as they call it, so the requirement to actually know who you're doing your banking with, who's doing these transactions, and sanctions. This is something that's been in the news a lot. So these are all different requirements in the regulation space. And the way that's playing out is actually that you have armies of lawyers and compliance officers in every single one of the banks, so spending billions of dollars a year. And what they're doing is processes just like I just described with walk and roll. They're running Google searches, they're going into internal database after internal database, and they're building a profile of that business. What's going on here? Who are they? They don't have an idea. They might have a credit card over here and a bank account over here. They're connected by their spouse. Who knew? And they're making a determination. Is this a suspicious activity? Now that takes them hours for just a decision that really should take a lawyer, if they were presented all this information, just minutes. So that's really where Enigma has been hopping in, is that we do the exact same process I described above with internal data sets. So we take their data, we access it programmatically before they even know that something's going on in regards to a negative anti-money laundering process. We augment that with public data, so we fill in the gaps, and now we've got a richer profile that's kind of a combined view of what our customers know about their customers and what we know from public data. We then use that to look up more information, and we're building this richer and richer model of your customer. Now, this is all before a lawyer even has to take a look at the case. They then open up their case, and they're actually, presented an interface much like this with all the information that they needed. They can make it a determination. So this actually, for each one of these areas of focus that we focus in, and I've mentioned a bunch of these, we can save hours per investigation that we're talking about. And these are hundreds of lawyers per bank across the world. But the nice thing about it is it's not just that, it's not just cost savings, it's actually building a much richer model of your business, right? You're going in and you're using this required compliance situation to build an understanding of your customer, right? And then you're being able to apply that back to marketing use cases across your business. So you're building this reusable asset that can then be shared among all these different groups who rarely ever spoke to each other before. So with that, I'll pause. A little bit about Enigma. We are a little over 100 people. We're located on 28th and 5th and rapidly growing. We've raised about $34 million to date, and our customers are largely Fortune 500 companies within pharmaceuticals, financial services, underwriting, hedge funds as well. And we have investors, both institutional investors out on the West Coast and here, and strategic investors as well. And some of our clients that you can see mentioned here. So I think I've got plenty of time for questions if anyone wants me to fill in the gaps here or go into more detail.